Hi everyone, my name is Omar Tolentino Rosas, and today I'm gonna talk about the sun. The sun is the star at the center of the solar system. It is nearly perfectly shaped of hot plasma with an internal condition mutation that generates a magnetic field by a dynamo process. The sun currently fuses about 6 million tons of hydrogen into helium every second, converting 4 million tons of matter into energy every second as a result. This energy, which can be taken between 10,000 and 170,000 years to escape from its cure. This is so amazing. The more as the sun changes the matter into energy, because we can't do that nowadays. Beginner characteristics of the Sun. The Sun is a G-type maintained sequence star that comprises about 99% of the mass of the solar system. The composition of the Sun. The Sun has a lot of elements around the Sun. As we can see, we have the hydrogen. The hydrogen has the 73% of the sun, and the helium is the 24% of the sun. The oxygen is the 0.77%. The carbon is the 0.29%. The iron is the 0.16%. The neon is the 0.12%. The nitrogen is the 0.09%. The silicon is the 0.07%. The magnesium is the 0.05%, and the sulfur is the 0.04%.
I'll give you a brief introduction of how the calculation of the distance between the Earth many years before. Knowing the radius of the Earth by Eratosthenes, which is 6,371 kilometers, we could satisfy ourselves getting more information. Using a little of trigonometry, the distance between the Moon and the Earth was calculated. 407,000 kilometers is the furthest point from the Moon and the Earth, and 357,000 kilometers is the nearest point to the Earth. Now, with this data, we can see some information. Setting the Moon in 1 1/4, meaning that the angle in the center of the Moon would be 19 degrees relating to the Sun and the Earth, we had enough data to calculate the distance between the Earth and the Sun. The Sun being known as a great object made of plasma and light, but great amount of elements, is the center of our solar system. The Sun, integrated mostly by hydrogen at high pressures and intense temperatures, which cause the nuclear fusion. Nuclear fusion is basically defined as two atoms of the same element united together to create a center and different elements, liberating energy in the form of heat and radiation. The basic element, hydrogen, join together to form helium. This is the reason why the Sun burns without oxygen in presence. If we could get into the Sun, we could notice how the temperature increases when going deeper into the Sun, to thousands and thousands of degrees. The main energy in the Sun is nuclear fusion. After millions of years, the Sun will run out of light elements, making even heavier elements, making it difficult to maintain the nuclear fusion and in consequence reducing the temperature until the last moment of life of our star.
Hello, I'm going to talk about energy from the sun. The solar energy received by the Earth is considered an important source of clean and renewable energy. This is used by natural cycles to produce energy, water movement, and wind movement. A main characteristic of the energy that comes from the sun is that it doesn't produce toxic waste and the maintenance is easy because it doesn't depend on an electrical supply. An example of this is the solar panels, where we collect solar energy to convert it into electrical energy. The following image shows use the percents of what happens to the energy that comes from the sun before reaching the earth. For example, 90% of energy is absorbed by ozone, steam, and dust, and 8% of the energy dispersed in the atmosphere, 4% of the energy absorbed by the clouds, 70% of the energy reflected by clouds, 6% of the energy reflected by the Earth's surface, and finally we have 40% the energy which is absorbed by the Earth. Another topic that I will talk about is heat given off by the sun. As we know, the sun emits light waves that can be of different types, and some are bad. For example, there are light waves that we see as colors, others that we feel in the form of heat. In this case, it's infrared light. The other is that we can convert into sounds. Here are the radio waves. And lastly, those that transport energy and affect health, for example, which are X-rays and gamma rays. Finally, I will talk about is geometric storm, also called solar storm. Is a temporary disturbance of the Earth's magnetosphère that can be caused by a solar wind, shock wave, or a coronal mass ejection. By the siglas are CMA, that interacts with the Earth's magnetic field. The increase in solar wind pressure initially compresses the magnetosphère, the magnetic field, and transfer energy to the magnetosphère. Both interactions cause an increase in plasma movement through the magnetosphère and increase in electrical current in the magnetosphère. In units, a geometric storm or solar storm has three stages. The first stage is solar eruption. In this occurs on the surface of the sun. The second stage is solar flare. In this stage, during a solar flare, a large amount of electromagnetic radiation is released across the spectrum from the rays to radio waves. The final stage is coronal mass ejection. After solar flare, sometimes a plasma cloud or coronal mass ejection is propelled, and in the event that the injection is directed towards Earth, and depending on the orientation of its magnetic field, it can damage satellites, electrical transformers, and radio communications. That's all.
What's up, guys? I am Orlando Reyes Rodriguez, and I am from Energy Engineering at Universidad Politécnica de Guadalajara Izcalli. And today I'm going to talk about the sun. And let's start with it. How big is the sun? The sun has a diameter of 1,390,000 kilometers, and this is a G-type of star. The spectral type is G, and the luminosity class is B. This is the center of the solar system, and it is the largest source of electromagnetic radiation. And as I said, it is the center of the solar system due to its enormous size, and it constitutes the 99% of the total mass. Well, the sun is made by many layouts. The first is the nucleus, the radiant sun, the convective sun, the photosphere, the chromosphere, the corona, and the solar winds. If you got the chance to go close to the sun, you could experience a surface temperature of 5,500 Celsius degrees. Well, the sun is mainly composed of the chemical elements hydrogen and helium. These both represent the 74.9% and 23.8% of the sun mass in the photosphere. As I said, it is one of the million of stars of the heavy elements. I mean, it is metal in astronomy that represents less than the 2% of the mass, with oxygen that represents the 1% of the mass. There are some other elements like carbon that represents 0.3, neon 0.2%, and iron that is equal 0.2%. Well, the energy of the sun in form of sunlight is compatible with most of the forms of life on Earth. This is through photosynthesis and determines the Earth climate and meteorology. The sun belongs to the population of the stars of rich in heavy elements. Well, the sun inherited its chemical composition from the interstellar medium through which it was formed. I mean, it is its content of matter and energy that exists within the stars within a galaxy through the galaxy. And to finish this, let's say its average density, that is 1.4 grams per centimeter cubed. That's all.